Okay, let's look at the example number 5, which is looking at also polynomials, except that here we've been given a polynomial px, and they are saying that the value of p of 3 is -2. So let's try and understand what is. So generally, when you have any polynomial p of x, depending on how you define it, p of x, let's say p of x is equal to ax q plus bx plus square plus cx plus k. This is a polynomial. Right now, if I have a factor, if x minus 1 is a factor of this polynomial, that means p, when I set this equal to 0 and I get x is equal to 1, that means p of 1 will be equal to 0 if this is a factor. Right? That means p of 1 will be equal to 0, and that means I'm not going to get any remainder, right? But if I have x minus k, if I divide x, but if this is not a factor, then p of k will give me a remainder. That is what it means. Okay, if this is not a factor, that means this just like when I have 4 divided by 3. I know 3 is not a factor of 4, so I'm always going to get 1 remainder 3, right? But if I divide 4 by 2, guess what? I get 2 remainder 0. So I'll always get a remainder of a 0 when 2 is a factor, when the polynomial is a factor. So in this particular case, we have p of 3 is equal to -2. That means when we take x minus 3 and as a possible factor and divide it through the polynomial, it's not going to set it because, but we're going to get a remainder of 2. So that is what this is all about. So x is equal to 3 is not a factor, but when we divide it, we're going to have a remainder of 2 at the end of the polynomial. So so this is just how you analyze it to see that the remainder when p is divided by x minus 2 is 2. So your answer is D. X minus 5 is not a fact. This is completely wrong. X minus 2 is completely wrong. This is completely wrong. So whenever you have a remainder, that means when you plug in the value of x, something will show up instead of 0. The remainder is not going to be 0. That is how you analyze this one.